Section 10.3 is operations with radical expressions. I can simplify sums and differences of radical expressions, and I can simplify products and quotients of radical expressions. Big ideas here. The properties of real numbers can be used to perform operations with radical expressions. The denominators of some radical expressions can be rationalized by multiplying by conjugates. Like radicals have the same radicands, whereas unlike radicals have different radicands. So if I have 4 square roots of 2 and -3 square roots of 2, these are like radicals because they're both square roots of 2. If I have 4 square roots of 2 and 2 square roots of 3, okay, these are unlike because those are different. We can combine like radicals similarly to how we combine like terms. In example 1, we're going to be combining like radicals. So the simplified form of each expression, here I have 6 times a square root of 11 plus 9 times the square root of 11. That square root of 11 is the same, guys, so it would be similar to if it was like 6x plus 9x. Here we'd keep our x's as an x, and then take 6 plus 9 to get 15. Same idea here, so I keep that square root exactly as it's written, and I can take and add the 6 and the 9 and get 15. Here, just like with variables, remember if there isn't a number in front or a coefficient, here it's a 1. So I keep my radical because it's exactly the same as square root of 3. And then I take 1 minus 5 and get -4. And just like with variable expressions, guys, radical expressions have to be exactly the same. So if I have 2 square roots of 3 plus 3 square roots of 2, those aren't the same. I can't add them up. Same thing as if I had 4 square roots of x and 3 square roots of x squared, for example. X here, x squared there, can't combine those together either, so I would leave them just the way they are. Now feel free to pause here and give these a try. What is the simplified form of each expression? Square root of 2 is the same in both radical expressions. So I keep that square root of 2, and I can take the 7 minus 8 and get -1. Part B, I have a square root of 5 and a square root of 5. So I keep it as a square root of 5, and now I can add them up. 5 plus 2 is 7. When we're adding and subtracting, our square roots are kind of like labels. It's how many of the same type of thing do we have? So how many square roots of 5 do we have? Well, I have 5 here and I have 2 there. So I have 7 square roots of 5. Again, kind of like a label. In example 2, we're simplifying to combine like radicals. So at first glance here, this looks like it's something that cannot be combined. But keep in mind that our radicals always have to be completely simplified. So here, okay, I have 4 times 3, and 4 is 2 times 2. So I actually have 5 square roots of 3 minus inside my square root, 2 2's, 1 3. 2 times 2 times 3. Here, I have a pair of 2's that can come out as a 2. So I have 5 square roots of 3 minus 2 square roots of 3. I keep that square root since it's the same, and I can take 5 minus 2 and get 3 square roots of 3. Now feel free to pause here and give these a try. What is the simplified form of each expression? Again, first glance looks like maybe it doesn't get combined, but here I can break this down into 4 times 7 and 2 times 2. So what I really have is 4 square roots of 7 plus 2 times the square root of 2 times 2 times 7. Those pair of 2's right there and here can come out as a 2. So I have 4 square roots of 7 plus 4 square roots of 7. Again, I keep my square root part as the square root of 7, and I combine my number parts. 4 plus 4 gives me 8. In B here, both of our radicands are composite, which means not prime. So here we can break this down into their prime factors. 8 and 4, 2 and 2, 4 and 2, and 2 and 2. So here I have 3 times the square root of 1, 2, 3, 4, 5 2's. Nine and 2 here, 3 and 3. And now we look for pairs. Pair of 2's comes out as a 2. Pair of 2 comes out as a 2. 2, 4, 12, square roots of 2. Pair of 3's comes out as a 3, minus 12 square roots of 2. So again here, I keep my radical part the same, and I can take 12 minus 12, which is 0. So I actually have 0 square roots of 2, and 0 times anything is just 0. So we have nothing left here, and we got 0. In example 3, we are multiplying radical expressions, finding the simplified form of each expression. So here we have a radical outside of our parentheses with a radical expression inside. So just like we would with variable expressions, we are going to distribute that in. So I'm going to take the square root of 10 times the square root of 6, and then I'm going to take square root of 10 times 3. And keep in mind that 3 is a whole number, so it doesn't go inside with our radical. Our multiplication property, our product property of radicals, says that we can take and combine our radicands into one square root as long as we're multiplying. I'm going to break these down into their prime parts though. Here, if we had 6 times 10, we'd have 60. That's not terrible to break down. But when we start getting into bigger numbers, guys, it gets a lot harder to break those down into their prime factors. So I think it's a little bit easier if we break them down from their individual radicals instead of the large product, but that's totally up to you, whatever you're more comfortable with. Here, we have a positive because both of them are positive, so I'm going to put a plus. My whole number goes in front, and I break down my radical. I'm going to look for any pairs that I can take out as a group. Pair of 2's comes out as a 2. So here I have 2 square root of 15 plus 3 square root. I have no pairs, so this is just a 10 again. And I cannot combine them because one's a 15 and one's a 10 inside my square root. That's all the simpler I can go here. In B, I have 2 things times 2 things. So very similar to when we had like a binomial times a binomial. And we're going to have to FOIL here. You could also use a table if you wanted. That would work too. So I'm going to take my firsts, outsides, and remember here we're multiplying, guys. Insides, and the sign goes with that number here, guys. And lasts. Every expression gets used exactly twice. FOIL. Now, just like we did in our last example, I'm going to try and reduce some of these here. So the square root of 6 times square root of 6, I have 2 times 3 times 2 times 3. A pair of 2's comes out as a 2. A pair of 3's comes out as a 3. And I have 3 times 2, which is 6. My radical is gone. 6 is 2 times 3. And it's positive here because I don't have any negatives. 2 times 3 times 3. Pair of 3's comes out as a 3. And I have 3 square roots of 2. Here the negative 2, remember, is a whole number. So inside my square root I just have the 3 and the 2 times 3. Pair of 3's comes out as a 3. And I have minus 6 square roots of 2. Last, again, my negative 2 is a whole number. Inside my square root I have a 3 and a 3. Those come out as a pair of 3's, and I have a negative 6. Radical is gone. Now, I can combine like terms. 6 minus 6, 0. They cancel each other out. And because I have like radicals here, they're both square roots of 2, I keep my square root of 2, and I take 3 minus 6 and get negative 3. So this whole thing, and this whole thing, and this whole thing, and this whole thing, all simplify down to be just negative 3 square roots of 2. Now feel free to pause and give this a try. We're going to distribute square root of 2 times square root of 6, and then the square root of 2 times a whole number 5. 6 I'm going to break down to 2 and 3. So my product property says I can multiply my radicands together, take out my pair of 2's as a 2, square root of 3. Here these are both positive, so plus whole number and 2 is prime, so 2. I can't combine a square root of 3 with a square root of 2, so that's my final answer. In B, we have an expression squared, and when we square something, guys, it means we take it times itself. And now here I'm going to FOIL. Firsts, outsides, insides, lasts. And again, remember to take those signs with those numbers. Here, when I multiply, I can take my 11's inside together, and they come out as just an 11, no radical left. Minus 2 square root of 11, minus 2 square root of 11, and in my last, I get a positive 4. 2 negatives make a positive. Now we'll combine those like terms. And because my radicals have the same radicand, square root of 11, I can take negative 2 minus 2, add them up, and get negative 4. See here, again, we're going to FOIL. 2 things times 2 things. 2 terms times 2 terms. Square root of 6 times whole number 4 times the square root of 3. Outsides. Insides, take that sign with that number. And lasts. Again, the sign goes with that number. Whole numbers I'm going to put out in front real fast just so I don't forget that they're whole numbers. And here I multiply them together and get negative 8. Here I multiply them together and get negative 6. Now, inside my radicals, I'm going to break down my radicands and write them as a product. So 2 times 3 times 3, 2 times 3 times 2 times 3, 3 times 3, 3 times 2 times 3. Pair of 3's comes out as a 3. Pair of 3's comes out as a 3. Pair of 2's comes out as a 2. So here I just get 18. Pair of 3's comes out as a 3. I just have 24. Pair of 3's comes out as a 3. And I have that square root of 2 left. Combine like terms, negative 6. Same radical part, so they go together. And 12 minus 18 is also negative 6. So negative 6 minus 6 times the square root of 2. And I'm going to pause here and I'll finish in another video.